For example, the first type of object that we want to talk about are indexes. What's an index? Well, an index is going to be some form of a guaranteed sorting of data. The most common example whenever anybody is trying to explain an index is to think of a phone book, that all the data in the phone book is going to be sorted by last name. That's guaranteed by the phone company, and SQL works the exact same way when we're talking about indexes. Now, creating indexes is very much a double-edged sword. It does take a lot of time, a lot of planning, some forethought, because what you'll notice about indexes when it comes to SQL Server is that indexes will generally lead to faster querying. The reason for that is because if I've got more indexes, when I go off and I execute a query, it's going to become more likely that the data that I'm looking for is already in the order that I'm looking for it to be in, or it's going to be in an order that will be optimized for the where statements that I will be executing. So generally speaking, having more indexes will lead to faster queries. On the flip side, however, there is no magic in indexes. Generally speaking, the more indexes that you add, the slower your modifications are going to be. The reason for that is that the indexes need to be kept up to date, and SQL is going to ensure that the data is always going to be kept in order. So as data changes, as data is inserted, as data is deleted, SQL then has to go off and find all the different copies of that data and make sure that everything maintains the guaranteed sort order. Speaking of maintenance, indexes must also be maintained by your administrator. Indexes are not going to automatically defragment themselves. So if I, for example, delete data, the space that was being used by that data is not going to be backfilled, so my administrator must periodically defragment indexes. Indexes come in two main varieties, clustered and non-clustered. A clustered index is the order in which your table is going to be stored. The best way to think about a clustered index is to think about a normal book and the page number for that book. That your page number is going to be the actual physical sort order of all the data that's inside of that book. SQL behaves the exact same way, that when we're writing data out to a table, and that table has a clustered index, SQL is going to ensure that all the data is going to be in the order that's specified by that clustered index. On the flip side, however, a non-clustered index is going to be a copy of the data, and that copy is going to be there for aiding with queries. The best way to think about a non-clustered index is to think about the index in the back of a book. That if I go to the back of, say, a SQL book, and I see that there's an index, what you'll notice is that the index will have simply keywords, and all the keywords will be in alphabetical order. So if I wanted to find all the entries, for example, on indexes, or on select, or on insert, then what I would do is I would go to the back of the book, I'd flip through everything, and I'd find the appropriate section. But of course, what would also wind up happening is it would contain pointers back to the rest of the data. So when I found the section on insert, for example, I'm not going to find all the information about insert in the index. That's not the purpose of the index. It's going to point me back to the appropriate page or pages that had the rest of the information. Well, a non-clustered index behaves the exact same way, that it's going to be a copy of the data, it's going to be in a format in an order that's going to be optimized for my queries, and it's also going to contain a pointer back to the original content. I think the simplest way to put together indexes is to take a look at a visual example. Imagine, if you will, that we had a customers table. So I've got my customers table with my customer ID, my name, and my join date. Over on the right-hand side, I have a non-clustered index. Now, as a real quick side note, you'll notice the naming there. Most indexes will be named with IX, short for index, underscore, the name of the table, underscore, and then the name of the column or columns that are involved in the index. So the index here is going to store name, and you'll notice that the order in which our names are listed is going to be in alphabetical order. So you'll notice that we've got Christopher, then Dave, then Karen, then Susan. But you'll also notice that we don't have all the information in the index from the customers table. For example, we don't have the join date. Because really, if we're going to make another copy and another copy and another copy and another copy, all that's going to wind up doing is taking up more space. The exact same concept again back in our book, that when we go to the index in the back, we're not going to have a copy of all the data all over again. What's going to happen is we're simply going to flip back to the page that had the appropriate data. Well, indexes, non-clustered, in SQL behave a very similar way. You'll notice that we'll have on that index the customer ID, and it's that customer ID that's going to point back to that customers table. So for example, if I executed a query where I said select name and join date from customers where name like Chris, what would most likely happen behind the scenes is that SQL would go to the customers index. It would find everybody that started with Chris% or started with Chris. It would find, in our case, the one record, and then it would go back to the customers table to go get the join date. Now again, as I mentioned before, when it comes to indexes, it's going to be under the domain of your DBA, your database administrator, or potentially your database developer, if your organization has one, to create and to maintain all of your indexes.